This is all of the information you're going to need about transformations. The thing about it is our copiers don't print in color. They unfortunately print in black and white. So what I need you to do is color code along with my version that's on the screen right here so that you have a nice colored copy of these notes. So we're going to spend a few pages. We're not doing the whole booklet today, but I'm going to put up on the board how I want you to color it. You can change the colors. Obviously, it's up to you. But you're going to highlight the information that's important, and I will bring your attention to certain things. All we're going to do today is color code and then use the booklet as notes. We're not taking any notes today. We're going to go straight into an activity because a lot of this is prior knowledge. So I'm going to stop talking, and I'm going to give you some moments to write things down, color code on this first page. So some things I want to bring to your attention now that we have it highlighted. We are working with transformations today. It's going to be called pre-images and images. The starting structure, the starting shape, the starting points are called the pre-image. What are they called?
The pre-image.
When you do a transformation, you have your final product. It's called an image. What is it called?
An image.
What do you notice is on both of these coordinate points on the image?
X1, XY, Y1.
Yes, but ones would be at the bottom. So these are actually called primes. So you would call this X prime, Y prime. Say that.
X prime, Y prime.
Cool. That's indicating that they are the final image. We have to put the primes on letters to talk about it being an image. There are 4 types of transformations. We're going over 2 of them today and 2 of them next class. The first 3 are called rigid transformations. You have your translations, reflections, and rotations. A non-rigid transformation is going to change the size of the object itself. That's only our dilations where you make them bigger or smaller. Huh?
Last year I learned.
Correct, yes. So we are still talking about the same things. We're just applying them to maybe more complicated shapes. Let's open this up and look on the inside. On the inside, our first page should talk about reflections. Again, let's take a second. Let's color code. Let's highlight. You can use the same thing I did or change it up. But I'm going to give you a few minutes to color code, and then I will talk about what's important on this page.
Like this?
Some things I'd like to point out about reflections. For reflections, they are flips over different lines. We're used to 2 of these reflections. Reflections over the x-axis means it goes from the top 2 quadrants to the bottom 2 quadrants or vice versa. So it flips over this direction. It means that you're changing the y value to the negative version, and that's it. Because if you notice, all the coordinate points just change the y value to negative. To flip something over the y-axis, it's going to go side-to-side flip. So quadrants 1 and 4 become quadrants 2 and 3. In this case, the rule says we are only changing the x value to a negative. So we go from having positive, positive, positives to negative, positive, negative, positive, negative, positive. So the x value changes. One thing I want to point out to you on these, and this is super important for me. What do you notice on all of the red images have I put on the letters? Ooh, it's not a 1. What is it called? Prime. It's a prime. So we would call this J prime, K prime, and L prime. That means that they're our final image of the object. Yes, we can also reflect over a diagonal line or a negative diagonal line, but the rules are here. What do you notice for this diagonal line, the y equal to x? What did I do with the letters? Flip them. We switch the x and y. Don't change the signs, just switch the x and y. So we look at the rules to be able to do the transformations for each of the coordinate points. Here's our last page for today. We're talking about translations. So translations are slides around the coordinate grid. Again, I'm going to give you a chance to color code. There's not as much here to color code. I did forget to type or write this part in for you down here, so make sure you write that in. My bad. I'll give you some time to think about the images and pre-images, and then we'll discuss some important stuff. So some important things to point out for you here. Slides or translations around the graph are just going to take the entire shape and move it left and right and move it up and down. Some important things to notice is that the x value, since the x-axis goes this direction, left and right, is going to change either left if it's minus or right if it's positive. So the number you add or subtract to x tells me if I'm moving left or right. For up and down, the y value, since the y-axis is up and down, will move the graph up and down. So if you notice, this one says plus 6 on the x, so it says right 6 because plus goes to the right. Minus says down, boom, down. All of these things have taken each of the coordinate points and done those transformations to move it around the graph. So translations are just slides around the entire screen. Just to talk you through some of the things I want to point your attention out to on this page. Obviously, we are rotating shapes. There are two ways we can rotate shapes. When they are on the coordinate grid, which is these first three rules, we are not rotating the shape itself like in a clockwise circle by itself. We are rotating around the origin. So if you notice, for a 90-degree counterclockwise rotation, which all of our rotations will be counterclockwise in this class, we are moving one quadrant around the origin. To do this, you just switch the x's and y's and make the first coordinate, which is the y coordinate, negative. So you flip them, change the first number to the opposite sign. To do a 180-degree counterclockwise rotation, again, you're going to take the shape and you're going to move it 2 quadrants. The way you do that is just by making both x and y negative. For a 270-degree counterclockwise rotation, you're going to take the shape and move it 1, 2, 3 quadrants around the graph, around the origin. You do that by switching x and y, but making the second term negative, the x term. The other way you can rotate shapes is, again, with the shape itself actually rotating around its center point. That's called rotational symmetry. I'm not talking about lines of symmetry anymore. I'm talking about rotational symmetry. This pentagon, if I were to rotate it, which you can see on my iPad, I'm going to zoom into it. It's not going to show up on the big screen, but if I put a pin in the center, notice that the point of the pentagon is at the top, and I physically rotate my hand, the point of the pentagon is still at the top, right? That has rotational symmetry because we can actually see it rotate around itself. That's what I'm talking about with rotational symmetry. Yes? Okay. On the next page, we're going to start talking about dilations. I'll give you some time to color code this one. There's not a ton, so I'm not going to spend a ton of time letting you color code, but we will discuss in a little bit what dilations are. So as you can see, as you color coded, for dilations, we're talking about making shapes bigger or smaller, but we're going to use the word enlargement and reduction. When you multiply the x and the y value by this scale factor k, you are scaling or dilating the shape bigger or smaller. If that k value is a fraction that is less than 1, like in this image here in example 1, we can see that the shape got smaller. We started from the large rectangular prism and then we got a smaller rectangular prism. That's a reduction, got smaller. If we're trying to find the scale factor for this one, obviously we can see it went from being a smaller triangle to a bigger triangle, so it's an enlargement. But when we find that k factor, that scale factor, using this process here, we can see that that number, 5 over 4, which is 1.25, is bigger than 1, so it made my shape bigger. Numbers bigger than 1 make it bigger. Numbers smaller than 1 make it smaller. Enlargement, reduction. On the two examples here, it's really pretty simple because what you do with this scale factor is you just multiply every coordinate by that scale factor. So negative 10 times 1/5, which is the same as saying negative 10 divided by 5, is negative 2. 0 times 1/5, 1 over 5th, what? 1 over 5 is 0. So we have our new coordinate point. We are dilating with respect to the origin, so it will move around your graph slightly, getting bigger, enlarging, or getting smaller, reducing. But for that, all you are doing is this right here, multiplying the x and y by some number k. This last page puts it all together. In fact, if you're the kind of person who doesn't love flipping through stuff but does a really good job reading formulas without seeing examples, this table that I've highlighted in green is going to be the best thing for you to look at because it has all of the formulas for you. However, if you need examples, you will have to flip through the book. Now, what is happening on this last page is a composition of transformations. You've actually done a composition before because when we did level 5 last time, it asked you to translate the triangle and then reflect it, which meant you were doing 2 different transformations at the same time. That's a composition. Your project is a giant composition of functions. You're going to take your shape and transform it a bunch of times. So if you notice in the color coding, I still have my pre-image, my starting as blue, and my image, or my final, as red. But in the middle, I have this intermediate step that's orange. Doesn't matter what color you make it. But if you'll notice, I had to do the orange translation first before I did the reflection. But I did the reflection to the intermediate graph, not back at the original. So you have nice examples, 4 examples of the different kinds of transformations we can compose together. I'm going to stop talking for a second, let you color code. This is our last page in our booklet.